It is day 13. We have officially reached the halfway point of this year's Advent of Code. It's also Friday the 13th, so let's hope for no spooky problem stuff today. Anyways, we are back today. Today's problem is building some sort of like brick breaker game, I've noticed. But anyways, for the first part here, we are given an encode program, and the encode program will run and output a long series of outputs here. The outputs are grouped in that the first are grouped in pairs of three, in pairs of three. And the first output in that group is going to be an X position, the second output will be a Y position, and the third output will be the tile ID. A tile ID of 0 is an empty tile, 1 is a wall, 2 is a block, 3 is the horizontal paddle, and 4 is the ball. So this program will run, basically I believe it's just simulating the game, and what we are doing, or the question is how many block tiles are left when the game exits. So basically we're just going to be mapping their outputs and kind of storing the game. So what we need to do first is actually store the game in some sort of int array. The issue with this array is I don't fully know how long or how big the map is. You know what? First, let's do this. Let's try and figure that out. So output state equals 0. So what we'll do is we'll calculate the output state. We'll replace this print line without, replace the lambda here. And what we'll do is, based upon the output state, we will do different things. Right, the output state needs to be finaled. Sorry, not finaled. It needs to be in a list of sorts here. Again, just because of the way I did it, we need to store it like that. So if the output state 0 equals 0, this will be the very first output, and it'll be the distance from the left. So this will be just x, and it's equal to out. So for now, let's make a temporary output holding the max values, and we're going to need just 2, so 0 and 0. So we're going to do a quick test of if the out value is greater than max values 0. If it is, set that equal to out, and we are good. Got final. Max value is 0, sorry. Oh, it's a long, by the way. Might as well just hold as a long. No reason to not hold as long there. Okay. And keep going along here. And also the output state is a 1. Or output state 1. Output state 0 is a 1. Sorry, backwards. And do that, and we should be good there. So now when the program executes, let's just output the max values. So the max x is going to be max values 0, and then the max y is going to be the same thing, but just index 1. So let's run this. Let's make sure that it works. We also have to increment output state. Actually, plus equals. How do we? Output state plus 1. Sorry, let's set equal. And 3. There we go. That way it'll loop around. So now if we run this, we get a max x of 44 and a max y of 25. Okay, so what we'll do is we'll create our map up here. Whoops. Private int array. So this will be the map. So the number of rows will be the number y. So this is our board. It's called the board. So it'll be 25. I'm going to just do 45 because it's a nice even number. Not that it's going to really matter. But I feel like let's do 40. Let's do 44. Never mind. Okay, so here's our board. So what we will do is output state, instead of max values, it's going to store the current values. So we're not going to be holding only the max values. We're going to hold the current values. And then when we get to the else here, what we will do is update the board at row, which is going to be current values 1. And the column, which is here, to be equal to what out is. We will cast out as an integer. Let's cast all of current values as integers too. That will make things a lot easier. And so just cast everything, since the indexes in these lists are okay. And then what we will do is now once the program finishes, we can just loop through everything and count the number of walls. Oh, sorry, row plus plus, but it's row is less than, I'll just do 44, not 44. It's board dot length. And same concept here, but instead of board.length, it is now board row.length. And this is now the column. Column, column, column. And what we will do is we will do int count. Do a quick check here. If the board at row column equals, what is the wall? We're calculating the walls, right? Block tiles, which is 2. So the ID is 2. Count plus plus, and for part 1, we will simply just output whatever that is. Print line part 1 and output count. Give this a run. Hopefully this will work. Unless we get an out of bounds exception. 44 is out of bounds. Interesting. Oh, are they actually one more than I thought they were? My bad. I said one more. 306. That actually worked. I'm kind of amazed, but I got that right. But yeah, so the issue here was that the max was 25, but that's 0 to 25, which means it's actually 26 in length. That's why this was calculated incorrectly. Anyways, though, that is actually part 1. I'm going to clean this up a bit to my code style real quick. But let me go ahead and go to part 2. Let me read it over and I will get back to you guys. Okay, so part 2 is actually sort of fully implementing the game. So what we are doing, or what things have changed, is that there is a joystick. The joystick is read through the input here, and it is neutral, or a neutral position is 0. Left is -1, right is 1. There is also, we have to edit the memory address 0 because we need quarters to play. So we need to set memory address 0 to 2. Can we even do that? Actually, do I even have a way to set memory in int code? I guess I just have to read it in the old way. Let me add a method in here that we can set memory. Or actually, yeah. Okay, so let's do public void set memory. And it'll be int address, int value. And it'll just be memory at address equals value. This way I can call this, if I spell memory right, that way I can just straight up call this from here. After we do encode program, we can do current program dot set memory of address 0 to 2. That should allow the free play. And now what should happen is we should be prompted for input, if I did it correctly. I would, but hold on, because there's one more part of this, and that there is also a segment display on this that shows your current score. If you get the instruction of x negative 1, y 0, that is not a tile, is in fact the score. So what I do quickly is, I shouldn't have condensed this. So what we have to do here is actually check if out equals -1. We need to flip a boolean here. Our output state is we need to flip a boolean to say boolean receive our setting score false, and then we also need to store the score. So private int score equals 0. We also add the private to these just to make it similar. Okay. So now we have setting score. So what we'll do here is we'll do setting score equals true. The y doesn't matter. We can still set the y like normal. On this, though, we have to do an else there. And then here on the board, we need to check if we're setting the score. If we are, we need to do score equals out. Let's change score to a long, just to make our life easier. And then reset the setting score to be false. Otherwise, go ahead and do the board like normal. So there's all that, and now we have score. So the last bit here, there's two things. One, we have to display the game, that way we can play it, and two, we need to get the joystick position. So actually, if we run this now, we should be stopped at the input. Good. So, displaying the game, we can kind of cheat the system a bit, and if we're waiting for an input, we can call display game, because this should happen like every game loop, quote unquote. So if we do display game, make this method public void. And what we do is we do this. And if we do a system.out.print, these will need to be like this. Whoops. Let's print out the game. So if we have a tile, let me get my Unicode. Block characters again. Let's do a lower half block. Sure. So print a lower half block, and then every time let's do a print line. Actually, what we do is we have to do a board here. Hold on. So the board is 0. Here. 0 is empty tile, so we don't care. So we just want 1 is a wall tile. Let's do this one. It's gonna be a half block. Oops. Print. Let's make it do that. Okay. 2 is the brick. 3 is the ball, if I'm correct. I don't really know what I want to do, so I'm just gonna do this. This is a smaller. 3 is the ball. Let me just verify. Or 3 is the paddle, 4 is the ball. So now 3 is the paddle. This is probably gonna look really weird, but let's do that. So they'll display the game. Hopefully it'll look correct in here. Probably won't. Oh no. Oh, we need 0 to output space. That'd be helpful. That'd probably be really helpful. Hey, that, you know, that looks like Brick Breaker to me. Okay, so these don't render correctly. Okay, so we need a different ball and a different paddle. That's unfortunate. Okay. So let's just make the paddle an underscore, I guess, and we can make the ball a period. Hopefully now. There we go. Hey, look, it's Brick Breaker. That's insanely hard to play in a console. Oh, we can actually like play. We bounced it. We bounced it, boys. It's actually playing Brick Breaker. Oh, we bounced it there. So yeah, this is like actually playing it. So the last thing to do is to just make our paddle sad. Our paddle bounce it. It's really hard. I might have to like figure this out because that's really hard to do. I don't know how else it's gonna work in console, but either way. Alright, so now for input. The last thing to do for input is keys. I haven't done keys in a while for Java. Stack Overflow to the rescue. So what I'm gonna do here is just copy some code here. Okay, so here's some input for key press I just got from Stack Overflow. I haven't done key presses in vanilla JavaScript. Haven't done key presses in vanilla JavaScript. Vanilla JavaScript. Vanilla JavaScript. Vanilla JavaScript. The only time I've done key presses is like in some sort of game design where I have a framework that kind of provides me the key input, like events and stuff. So this is kind of new to me, but basically we just had the key event. The key event will give us the key ID. So what the key ID, and then it will also tell or the key ID. No, sorry, the key event, which tells us if we're pressing the key or releasing the key. So all we want to do is listen for the key press and release. So the press will check if it is VK. Let's just go A, VL. Sorry, VK. Let's just do A. And what we need a private int input. This will just be constantly fed to input. What'll happen if you press A, we will set input equal to -1. Otherwise, if it is D, we will just specify that input is equal to 1. Clean this up a bit. And then what we'll do here is the key released. We don't care what key it is because I'm just gonna say, no, we do care, but what I'm gonna do is I'm gonna put these together. So if the release key is one of these two, doesn't matter which, I'm just gonna force it to 0 just to make it easier. There we go. So now we have input. We can give input over here. So instead of doing a scanner, no scanner is needed. We can just simply roll the input in based upon the key we're pressing. If you don't know, this whole synchronized bit is just for threading. Don't worry about it. It's not a huge deal. And then, oh, last thing we need to do is we also need to display the score at the very top. So we'll do system.out.print line score. There we go. So now if we give this a run, it should probably run really fast, too fast for me to play. So we need to slow the game down. Okay. So to slow the game down, we can do a display and then we can do a thread sleep. This is terrible. Never do this. 1 second. Oh no. This is definitely a terrible, terrible. Don't do this. I should have put this in try catch. There we go. I don't know if this will even work, but we'll find out. Oh, well, it would help if this automatically scrolled. The output doesn't automatically scroll. Oh wait, it will. I just need to put the output in that state. Okay, bounce. Wait, how do I... Hey, can I, is that impossible? No, it doesn't, it won't take the input in. I mean, I could play it via the actual, like, inputting a 0 or a 1. I thought this would be cooler, but I think I might have to play by inputting a 0, a -1, or a 1. You know what we can do? Screw this. We don't need to do any input, because we can just cheat the system because we're coding this. So instead of actually doing input like this, what we'll do is every time we need an input, we will check. We need to check the ball's current location. So what I'm gonna do is I just need the ball's X. So we're gonna do private int ball X. And whenever we output, if the else, we're gonna do a quick check if out equals, what's the ball's ID? The ball's ID is 4. If out equals 4, set ball X equal to this. And then every time we ask for an input, what we will do is we will compare the ball X to our current X. Or just do paddle X. So if out was 4, do that. If out is 3, the paddle X is that. So on the input, paddle X is greater than ball X. What we will do, if that is true, if the paddle X is greater than ball X, we will set -1. Otherwise, let's check the opposite direction, because if they're equal, we'll put 0. So if paddle X is less than the ball X, we do a 1, otherwise a 0. This should make the game run really fast. Oh, we can just intercompare. Oh, that's nice. The game should run really fast now and basically just straight up finish. Or maybe it won't straight up finish. Always gotta play the entire game. Hold on. Let's let it play the entire game. Hey, we got them all. And our score is that. But that's before we hit the last one. I'm pretty sure that's gonna be wrong. How much points do we get for hitting one? 3, 2, 2. Where is the where's one with the 2 on it? You usually get 15 points, so 37? Too high. Okay, that's fine. It was too high, so let's just put in what we got. I gotta wait a minute here. But yeah, so that was very interesting watching that play. So yeah, this is kind of just computer-wise playing the game. It's just matching the paddle's X to the ball's X is what it's doing, or what it's attempting to do. And yeah, unfortunately, I couldn't. I wanted to be able to play it. I really wanted to be able to play it, but unfortunately, it's just not possible. just given what I'm doing. So sadly, I can't actually play it, but this works to have fun. But that's actually kind of cool. It just straight up plays it. Actually, you know what we'll do is we'll do part 1 here. Part 2 is going to be equal to score. Let's have it run that. I'm curious if that. I don't know where that came from. Part 2 score. This might be a better way to get the score for your output. Run this again. Let's watch it play in our console. Doesn't look like it's very good, but get that last one. Oh, 2-8. So we've been wrong anyways. There we go. Got the gold star. We got both parts. Today was actually pretty fast. 28 minutes without editing. So that's probably the fastest I've done it since like day 2. But that's pretty cool. We got to play Pong in int code in our console. So this wants an enhanced for loop. It wants an enhanced for loop. So I'll let it do enhanced just because I like not having errors. But let's run through. I can run through the code to summarize what we did today. So we used our int code program we have used many times in the past. We loaded it in. We also set the memory. I added a method to set the memory of a certain memory address to a value. Well, what we did is while the program is running, every time it waits for an input, we display the game. This way, this is kind of like how normal games would be. If you only have a update loop, you would display an update in the same loop to kind of discern your rendering versus your updates. So I'm just kind of utilizing how the game would ask for input after one draw to be able to draw the game in our console. Neat little trick. And then as the game executes and outputs, and wants to output something, we read off which state it wants to, because the first output will be the X, the second output's the Y, the third output is either the score or what goes there. So we kind of utilize our output to keep track of the state of output it's in, do that accordingly, and then we display the game. Let's actually move part 1. Let's keep part 1. Let's move this for part 1 up before the game goes. But it's not going to. Never mind, we can't do that. Okay. Either way, that is it. That is day 13 done. That is our int code Brick Breaker breakout game complete. Hopefully you guys enjoyed. I will see you guys all tomorrow for day 14. Peace out.